Ryan, joined by the ever forgetful Ben from Cinema Bureau. I'm going to hold that over you. I'm never going to forget. I'm not important enough for you to remember. You have to be working in order for you to remember poor old Ryan.
I remembered a couple of days
forgot.
ago. Then, yeah, sure. It's another bank holiday here in the UK. So, having been off work quite a lot of last week, unwell, I was cleaning my patio today, and my wife was kind of, "Aren't you supposed to be at the office?"
What a turd.
Yeah, I probably should go in.
What a turd you are.
Have fun and argue with Ryan a bit today.
Yeah, we're going to argue, maybe. Or we're going to agree. Ben thinks we're going to disagree. I don't know.
Nor do I. But so we should say that as much as we try not to prep, we do normally talk for maybe 10, 15 minutes before every episode and just run through what we're going to say, like some key talking points.
We didn't do that today.
We usually agree on a lot of stuff, right? So I think one of the reasons we get on is that we see a lot of things the same way. But where I think today might go, I suspect I've got some controversial views that you might disagree with. And won't it be way more fun to have a debate instead of just, we don't need this every single week to be just a yes, ass kissing, we agree on everything. If we disagree, let's do it in public. It'll be a laugh.
Yeah, maybe. Or we'll
see,
be
right?
totally discredited and nobody will listen to us anymore. But we're going to find out. Okay, so today's topic is amplifiers. Do you need an amp? And I think the best place to start for this, Ben, is at the general consumer level.
Right.
I think I know where you're going to go with this. But at the general consumer level, do you think, I'm going to ask the question, do you think the majority of people need amplifiers, dedicated amplifiers?
Probably not.
Yeah, I would agree with that.
That's really difficult for me because the answer to every single audio question is it depends.
Yes, it depends. But in the average use case for, let's set out some stipulations here. If you're not chasing SPL, right? If I'm listening at low to moderate volumes, my seating distance isn't a mile away from the speakers. I do not have speakers that have a sensitivity of something absurdly low. Do you think, and that's the average person, right?
Right.
At that point, do you think you need a dedicated amp? And my answer for the majority of people is no. The amps in an AVR typically are more than enough for the average Joe.
Yeah, fair. So here's where I'm going to get controversial already. I'm just going to go for it. Quite a lot of research comes out that all amplifiers sound the same, but we can't tell the difference. And that's backed up by ABX testing. So if you get a load of enthusiasts to do an ABX test and listen to different amplifiers, they can't tell the difference.
Right.
So that's interesting. And here's my problem. I think that's a fault with the test, not with the amplifiers all sounding the same. So, right, and here's where we'll probably disagree. But we can be sure, right? Things we can be sure about is the room and the acoustics of your room absolutely make a huge, profound difference. If you've got some money to spend and your room's not right, fix your room. Speakers absolutely make a huge difference. Directivity, the tonal balance of how, like, everything about speakers makes a big difference. If your system doesn't sound how you want and you've got some money, speakers, right? Amplifiers is
or
definitely
subs. Yeah.
Right. Subs, speakers, the things that really change, right? Amplifiers are way down the pecking order in terms of making a difference in sound on one condition. And this is where I think some of the ABX tests fall short of some honesty, is a well-made amplifier sounds the same when you're well within its operating capacity.
Yes, I agree.
Where they sound different is as soon as you start to push them harder.
Oh, for sure.
When you get to its limits.
Yes, I fully agree.
The idea of an ABX test, and when the last one came out, I think it was published on Headphony or one of the websites, that basically got sent all around the internet as absolute proof that nobody can hear the difference between amplifiers.
Yeah.
And that's fine if you do a level matched A/B test and they sound the same.
Yes.
That's great. The problem is that's not how we actually live. We don't live in a level matched world. We live in a world where we might turn it up one day. We might so if you give me 2 amplifiers and say, go and find out which one of those you like best, in different cases, I'll tell the difference, right? And so the really clear answer on this is, and I think it's one that we both are familiar with, so that's fun, is take the regular Ascendo 10K amp against their 10K infrasonic amp. Both 10K, both got the same output. Do they sound the same? Not a chance.
One's going to have a really bad noise floor.
One of them is, they're vastly different in their power supplies. So one of them can sustain long, low outputs without rail sag. The other is not built to do that. You know, it's great at 20 hertz plus, quick, snappy, bang, booms, kick drums.
I think what you're saying is, and I'm going to kind of tell me if I'm wrong in what you're saying. All amps sound the same as long as you stay within the bounds of their capabilities. Once you start deviating and pushing to the limits, like with the 10K amplifier, right? If we're talking about subs, if you start pushing their limits, in this point, pushing to really low infrasonic frequencies, one's going to run out of gas.
Right.
And you're going to run into clipping. You're going to run into distortion. Yeah, I fully agree with that. No question. I think it's really important, like everything else, you use things within the capabilities of that equipment. If you start pushing to the limits, you need better equipment.
Sure.
Because the other stuff's going to run out of
100%. And the way that products sound as you push them into different use cases will be interesting. So there's a bit of a back and a forth here that we can say, right, so you've got an AVR, and we'll talk in depth about AVRs in a minute and how they're rated and what those ratings mean. But we only listen to it at a certain level, right? So we're not pushing it very hard. We're only listening to X level. And the AVR does a great job there. Another amplifier at that level doesn't sound any different. But why are you listening at that level? It may be that you're listening at that level because when you turn it up louder, it doesn't sound great. So you don't turn it up louder. But if you had an amplifier with better capabilities that was clean when you turned it up, you might listen a bit louder. So are you listening at that level because that's truly where you want to be? Or are you listening at that level because your kit is not capable of going louder? And when you A/B at that level, they sound the same.
That's an interesting deviation from the typical ABX, and I think I need to do that at M-Wave. And I fully agree with you. I think you thought that I was going to go a different direction, and no, you need to stay within the limits and the capabilities of your equipment. And if you start pushing things hard, you're going to run into how those amplifiers deal with different impedance swings. You're going to deal with different output and how where they're compressing. I mean, there's all different kinds of things that I think objectively, if you talk to somebody and said, hey, you need to consider these, and you actually explained it, I think the majority of people would agree. But you are right in that a lot of the ABX testing that has been done has not tested for that. It's tested at a neutral level where they're all level matched at a moderate level that's not overtly loud. And at that point, yeah, the majority of things are not going to sound any different unless it's poorly made or intentionally coloring the audio, and this doesn't mean it's bad, like a tube amp or something. That is a deviation intentionally.
Right. So I guess the bit I thought we might disagree with is the value of an ABX test. Because I totally believe in the value of an ABX test.
Yes.
But within limits. Because if you're just trying to prove that we can't hear a difference at that exact use case, that's only valid if that is the only use case I'm going to have.
I mean, you could, if you did it at the extreme use case, you could surmise that at a lower output level, it's going to be able to handle that as well, as long as the noise floor was adequate. So I think the key there is if you're doing the ABX test, you need to push a little bit further. We're not pushing far enough to get in a truly objective result.
Right.
I think is what you're saying.
Yeah, kind of. It's more I mean, that's one way to find it is, if you run that test at different levels, and see if a difference occurs once you start to go louder.
Yeah.
And it's easy to say, you're right, but I don't want to listen louder.
Yeah.
But you and I both listen way louder than most people think we should.
Oh, yeah.
And we say we do that because it stays clean and it's effortless. Well, we only discovered that we listen loud to clean, effortless systems when we built clean, effortless systems.
Well, the interesting part is people go to concerts and they do this all the time. And they're like, oh, I listen loud. And they don't realize that the SPL you're listening to peak at a concert is well above your typical home theater listening level. And why is that happening? Because the pro equipment that's being used is not distorting. And you're not getting room modes and things, because the rooms are typically huge or you're outside and things like that. But yeah, I think a lot of people will listen louder than they otherwise think they will if they give themselves a correct pathway to doing this. I had a couple guys in last week and we had this exact same discussion. And at the end of the demo, and this is crazy for me doing this, at the end of the demo, we were pushing into the high 130s, low 140s.
Yeah.
And they looked at me and went, and I showed them the SPL meter, and they looked at me and went, it's really that loud? I'm like, yeah, I'll show you. We'll calibrate it right now. And it was.
Yeah.
It was. And a lot of it's low end energy, because there's a lot of low end energy, base energy, and you're adding in a bunch of stuff, but you listen a lot louder than you think you are, and it becomes effortless. Okay. Enough about that. Let's actually talk about some of these use cases. And I want to start with the average Joe. And I'm not saying the average Joe is bad. The average Joe is your typical use case. And this question comes up all the time. Well, actually, before we go into that, I'm going to go back to your ABX test, because I think this is a really important caveat. If you're going to run this test, it is very, very, very important that you consider all variables that may impact as you turn up the volume and you're asking from the amplifier. Because if you have a speaker that can't keep up with that, well, now you've just invalidated your whole test.
Right.
Because the speaker is going to distort and it's going to make everything sound like poo when the amplifier may be doing perfectly fine. So it's really important that when you do this, that you get and control other variables that are not going to impact what you're actually testing for.
Yeah. I would just say, I think the tests that show that all amplifiers sound exactly the same are just disingenuous.
I don't, a lot of them do sound the same at a moderate level.
Sure.
I think I would agree that they're not saying that last bit. And I think that's important. We harp on specs all the time. And part of that is we need the testing criteria for that test. And I don't think in the majority of testing that is provided. Like, what was your level? What levels did you test at? What was the room like that you tested in? What, all of this stuff. And now headphones, they'll say these were the headphones we used, blah, blah, blah. But do they say, maybe they do. Do they say the SPL that it was tested at? I don't know. I've done this test and I didn't consider this.
Right.
And I need to, because we listen a lot louder than we think we do. Now, I will say that
you only listen louder than you think you will if the system's clean and capable of it.
Yes.
And that's the key. That's the problem is, let's take all factors out and say, right, you've got the speakers are capable of it. The room acoustics are great. You've got an amplifier capable of 100 watts per channel and one capable of 400 watts a channel. Would you in real world listen to them at the same level? You don't know, but it's possible that with the more powerful one, because it can deliver more power cleanly, you might listen 2 or 3 dB louder, and you might get a different emotional response from that extra level.
Mm-hmm.
Might become more physical, it might become more immersive from that level, and therefore, the question now changes. At the same level, let's say when they're both pushing out 20, 30 watts, they sound the same. But if you push from up to 100 watts of output, one is now right on its very edge, one is still way within its capabilities, they're going to sound different. One's going to be clipping, it's going to have huge like harmonic distortion. It will be awful. It will sound loud because harmonic distortion sounds loud. It's terrible. So if you can do that ABX test, what almost everybody that publishes results will have done is they'll do that test at 1, 2, 3, 10 watts. I want to see it at 100, where one is on its edge and one's not, at which point they won't sound the same.
No.
And then we can say amplifiers don't all sound the same.
Yes, I would agree with that.
If you go into the test wanting to prove all amplifiers sound the same, you set up conditions where they'll sound the same.
Yeah. Now, a caveat you just put in there, or a tidbit that we need to talk about, is you said if you wanted to listen at 2 to 3 dB more. Now, to somebody that's not in this industry or not an enthusiast or is a fledgling enthusiast, which none of that is bad, 2 to 3 dB more may not sound like a lot, but when you start getting into these upper SPLs, you're asking a lot more of an amplifier. Because if you're, let's say you're at the limits of that 100 watts and you say, okay, I want to add 3 dB more. What happens? How much more power do you need to add for that to happen in that ask from the amplifier? Every 3 dB of power, ladies and gentlemen, and a lot of you guys will know this, every 3 dB of output, I should say, is a doubling of power. So you're going from 100 watts to 200 watts. And then if you want to ask another 3 dB from this, you've now gone from 200 watts to 400 watts. So it gets out of control exponentially quickly, which is why you say amplifier should be way down the list, because an easier way to fix that is to get a more sensitive speaker.
There's a balancing act of where to change it. And it's interesting how this ramps up really quickly. You know, when you're adding we take measurements at lower levels, right? So you're putting in 2.83 volts. We reference it to 1 meter. It's easy. You know, we go up from there. We're not adding much power. You know, if you imagine going from 1 watt to 2 watts to 4 watts, we still went up 6 dB. From 1 watt to 4 watts is 6 dB of gain. But at the other end of the scale, you've got to go from 100 to 400 to get that same 6 dB. Once we're trying to add more power at the top, hey, like, it's the same. You know, we both have relatively nice cars. Mine not as nice as yours, but
that's not true. You have a great car, but that doesn't matter. I get what your point is.
It doesn't compare to what you told me you're building. But let's be fair, right? You know, my car has quite a lot of horsepower. It will run out of steam. You know, we're both going to be fine at highway speeds.
This is actually a good analogy.
At highway speeds, easy. They're both going to be comfortable, moderate. You know, they're fine. But when my car is at the max of its torque, it's, you know, completely gassed out. How much more power do you need to make it go faster? A lot.
A lot.
Air resistance is squared or cubed. It's massively exponential. So it's a similar kind of thing. Is how much more power do you need to go from 10 miles an hour to 20 miles an hour? Not much. To go from 100 to 110 to 120 to 130 ramps up real quick. Yeah. So if you want to push a system louder, the power goes through the roof. And then what we haven't really discussed is what that power really is. Like, so you've got a voltage component and a current component. And as soon as you run out of either, you're in trouble. So to make it louder, we need more voltage. We need a bigger voltage swing. But whenever we see tests done, like if, you know, I could go onto one of the sites that do tests, they've got an audio precision, they do all the tests, but their dummy loads remain. You know, it's an 8 amp load or a 4 amp load, but my loudspeakers aren't the same impedance at all frequencies. That doesn't factor in what happens as this amp gets hot. Like if we do a 1 minute test, great. I don't watch 1 minute movies. I watch 2-hour movies really loud. So does this amplifier still behave that same way 2 hours in when I've been taking the piss out of it and it's now screaming hot? Does it still behave like it did on the test bench in the lab for 1 minute? Doubt it.
Yeah.
So like we're data first, but I don't think the data that's in the public domain, even being done by independent testers, tells us the whole story.
I think it could. They're just not testing the correct things in a lot of these situations.
Yeah, I think
They
there's a
could
lot more
test
things to
this.
measure.
Yeah. They're not. And the easiest way for you to fix this is I've got 2 speakers here. I'm not gonna show the spec sheets because I don't think we need to. But 2 speakers. One, both are excellent speakers designed for different things. One, and I'll just say what they are because they're both great speakers. One is the Kef Blade.
Yep.
Kef Blade, amazing speaker. If you ask Kef at the beginning, they're going to say this speaker's not designed to get to absurd SPL levels.
Sure.
It's not what it's supposed to do. It's got a razor flat frequency response. It has an amazing capability in virtually everything in a spinorama. It does phenomenally well in virtually everything. But, and this isn't really bad, it has an 88 dB sensitivity at 1 meter, 2.83 volts.
Yeah.
88 dB, which isn't bad. But if I'm chasing volume, if I'm chasing SPL at X seating distance, that's potentially going to be a limitation. And the reason I bring this up is because you said at the very beginning, and I agree with you, the amplifier in the pecking order is way down here. It's way down here. The easier way for me to fix this, instead of saying my amplifier is capable of 2,000 watts, because most amps that are capable of 2,000 watts are going to be probably pro amps. They're going to have a lot of noise in their output because they're chasing output for concerts. They need huge amounts of power in order to power these huge systems. So not great for a home theater system. The easier way to fix this, if you're chasing volume, and I always harp on this, get the correct tool for the job. If you're trying to get SPL, Blade 1, if you're trying to get to something outside of its capabilities, is not the correct tool. If you look at something like an Ascendo Black Swan, the Black Swan, at least on its tweeter, 117 dB capable, which is insane. That's at 1 watt. So and it does that because the tweeter is enormous. At least the original one was. There's been some changes, but it's a 4-inch compression-driven beryllium tweeter, which is insanity. But 117 dB. So now I have to ask and this is an extreme example, far less of the amplifier. And I'm already gaining 30 dB. Just
how much power do you throw at your tweeters?
I'd have to calculate it. Not a lot. I have to throw a lot more at my woofers than I do the tweeters.
Are you using the ULN2s?
No.
Okay.
I need to put a watt meter on them. I've got the Storms, the PA 16s, then the Amplitude 16s.
Right.
So I think it's just 200 watts, but I don't need anywhere near that on those.
No, that's fine. I was just surprised when I did the math. So the amp that Ascendo makes specifically for a Black Swan has 2 outputs. One has a lot more gain than the other, so that you don't put loads of noise on that noisy horn. And I was surprised when I did the math. So you can run it bridged or not on the high frequency side. So it's 140 watts unbridged. It'll go up to 280 bridged. And knowing the sensitivity, when I was speccing some, I was like, why would we ever need to run it? Oh, I do need to run it bridged. God, we still need the power.
Yes.
It caught me. I was not expecting it, but that's what happens in really big rooms when you want to play really loud.
When you play and when you sit really far away and or you got really big rooms and you're asking a lot of it, and this is why you need pro amps that have huge amounts of power, you're gonna need it.
Yeah.
Even at those high sensitivities. And this is a big reason why if you look at a lot of pro speakers, they have really high sensitivities in order to mitigate this, because if they had low sensitivities, I mean, you'd be pushing absurd amounts of power and then the heat ramps up. It's a lot. So my argument with everybody is always start at the foundation and use the correct tool for the job.
Right.
Like, don't try and shove a square peg into a circle hole. It's not going to work. So you've got to start by using the correct thing. Look at, what am I trying to get to? What is my experience supposed to be? What am I trying to obtain at the end? And then put tools, i.e. the equipment, the speakers, the amplifier, that allow you to get to that while being constrained by any of your budget, your space, your power, all of that, whatever it may be. Pick the tools that get you to that job instead of picking the tools and then trying to figure out, well, can I get to the experience that I'm trying to get to? That's the wrong way to go about it.
So I guess on an AVR, one of the things that can determine if it's the right tool, because we don't get enough data from manufacturers. That's key. A couple of questions have come in from what I've said, and we'll address them specifically. But I'm not saying the tests aren't valid.
No,
I'm saying we don't have enough tests. So the tests are valid at what they show. I think we need to see other things as well as the tests that we can get access to. So if without independent testing, we get a spec sheet from a manufacturer, and we normally slag off spec sheets from speakers because that's more fun. But AVRs, they're really guilty of giving us rubbish specs too. So I have a manufacturer up. I'm not going to say who it is. We don't need to say that. But it's a 7.2 design system. So it has 7 output channels, 7 power amps in it. They give me 3 figures for output. Power output, 8 ohms, 20 to 20, 0.08% distortion, 2 channels driven, 95 watts. Okay, right? I know, I can understand, right? That's a full range signal. I know how much distortion there is. They're running 2 channels. The next one is power output, 6 ohms, 1 kilohertz, 0.7% distortion, 2 channels driven, 125 watts. So that's a completely different spec to the 95 watts. They basically tell me very little like that's comparable there. Then I get the next one, power output, 6 ohms, 1 kilohertz, 10% distortion, 1 channel driven, 150 watts. Now, if you look down this list and don't accept the difference of why those specs changed and think, oh yeah, it can do 150 watts. Right, it can do 150 watts with masses of distortion at 1 kilohertz, 1 channel driven. Well, what happens above and below 1 kilohertz? Because we could find, and this depends on the amplifier topology. I am not an amp designer. I am not an expert on the differences of how class A, AB, class D, class G, class H, all the others behave once you like different things. But I do know most transistor solid state amplifiers are using a negative feedback loop. And that will have an effect. That has an effect with different transients, have different effects on that. But it also means that they are not going to remain completely linear as you start to push them. So it might be that as we drop down to a 4 ohm load, that speaker starts to roll off at 10K. Once we drive the level up, right? So we've got a 4 ohm load, we push the level higher, we're asking more of it. And actually the high frequency output rolls off from about 10K. Like this is potential what can happen in a solid state amp. Into an 8 ohm load, it might not roll off in the same way. So actually this amp would now, when pushed, sound brighter into an 8 ohm load than it does into a 4 ohm load. That's presuming that these speakers are actually 8 ohm and 4 ohm up above 10K, which they might not be if we just have a nominal impedance. We don't really know till we see a full impedance plot. But right, who wants to listen at 10% distortion? Because I sure as shit don't.
Unless I'm listening to a subwoofer, I don't.
Right. You know,
And
potentially
that's a good point. That's actually something we need to highlight is as the frequency goes down, your tolerance for distortion is going to increase, especially as you start getting into subwoofers. Now, there is a point, but this is why if you look at a lot of subwoofer measurement data, they are distortion limited,
right.
right? At what harmonic it is. And as you get down further and further and further, especially as you get into infrasonics, our tolerance for distortion goes way up. So it's not universal that I need whatever below 1% distortion. It varies depending on the frequency and the wavelength.
Yeah.
So just want to throw that out there. It is a caveat, and it is very important to realize that a subwoofer amp is probably going to have higher distortion than a speaker amp, especially as you're asking it to play lower and lower. Now, I'm going to put somebody on a podium here. I think Amir from Audio Science Review does a pretty good job of testing amplifiers.
I think he does an incomplete job, but what he does fine.
He does. I would like him to do more, but he does provide, he's one of the only sources that I'm aware of, provide an insight into what an amplifier is doing. So that we at least have some information. I wish the manufacturers would give us more. But
right.
He does help it. So if you're trying, before you buy an amplifier, I highly suggest you go look at what's going on so you can at least evaluate what has been tested.
So based on like my concerns about the ABX tests that are done, I have a concern that the data that Amir publishes doesn't tell you enough of the story to really know what's going to happen in real world.
Yeah. It's better than nothing.
Sure, absolutely. And in the things it does compare, it now gives us an apples to apples comparison. So we can say, yeah, under these conditions, this one is better than that one.
Yes.
And the conclusion that is often drawn on that website is all competent amps sound the same. Because
that is fair.
Under those conditions, they do. The problem is those conditions aren't real world.
That is fair. Now, I want to get back to the average Joe, and what I mean by the average Joe is the questions that people normally find themselves in.
Yeah, I was going to say that. So that data I've just gone through from that amplifier, like we don't really know, as they give those bigger figures, we don't really know what's happening outside those parameters. We don't know what happens when you ask 150 watts, what's happening above or below 1 kilohertz. But what is really telling on an AVR is its maximum power consumption.
Mm-hmm.
I think that's like actually the most telling thing, because I don't listen to one speaker ever. Like, how often do you have a mono system in a movie playback? Right, almost never. There's loads of stuff happening across multiple channels. We could easily pull out meters and show how many channels are being driven hard at times. You know, Ready Player One is one of my favorites to point out, of really difficult to reproduce. There are times when almost every channel is maxed out, right? So one channel driven is totally irrelevant. But this particular AVR, across its 7 channels, has a maximum power consumption of 500 watts. So we can get an understanding. It's not going to be able to max out 7 channels at 150 watts output that won't be perfectly efficient if the maximum that ever pulls from the wall is 500 watts. It's not going to happen.
Yeah.
I go up their range to a product that costs twice as much money. It has 9 outputs now, and its maximum power consumption has gone up to 660 watts.
Mm-hmm.
Okay, well, that's telling. It's trying to drive more amplification.
I know what AVR you're talking about, because I'm looking at the same one.
Yeah, we're probably guilty. But we haven't named them. It's fine. You know, we're not going to get sued by them. But it doesn't look like, when we look at 2 channels driven, I now have a figure of 105 watts, 8 ohms, 20 to 20, 0.08% distortion. It's a bit annoying that their lower end product was measured at 0.0. Oh, no, sorry, it was 0.08. It's the same. Okay, so it's 0.08, 2 channels driven, 95 watts on the lower price one, 105 on the more expensive one. So you're paying twice as much money, and it's 10 watts more output at 2 channels driven under the same conditions.
But average Joe, at least it's not an enthusiast, is going to look at that and be like, I can get louder. 10 watts is like a fraction of a dB.
Right.
When you're pushed into this level.
Exactly that. So this is the key thing, is once we're up at high levels, those 10 watts do square root of sod all for more output.
Nothing.
Really. But what we have got is 150 watts more power supply.
Yes.
So when we start pushing multiple channels, we've got 100, whatever it was, 660 against 500. So yeah, 160 watts. That 160 watts more power supply is going to get really useful as we're driving multiple channels. And that is way more telling than those extra 10 watts under the same test.
But I think instead of doing that, instead of buying the more expensive AVR, especially if it doesn't do anything extra,
right?
Like settings wise, output, whatever, I'd rather buy a dedicated amplifier and use the pre-outs.
Yes.
Yeah.
Probably.
You're going to get a better experience doing that. You're going to get way more power. It's just a better use case of the money. So that extra power that you're getting, while it can help, if that's all you're going to do, I think your funds are better allocated getting one that meets all of your criteria, settings, feature-wise, and then using that extra funding to get a dedicated amplifier, at least for LCRs.
And then, so we can do some maths and show when you're going to be too loud or need more power from an AVR. But before I kind of like break down some maths, here's what's interesting is if you go and buy an amp, making sure you buy one that's right and compatible with your system. So did you say earlier you've got amplitude 16s?
And
right.
PA 16.
I love the amp 16. I think the amp 16 is a great product. It's quite often. Love it, right? So, hey, I'm really brand agnostic when I'm slagging people off, but when I like things, I'm happy to tell you about it. Sue me.
They are great amps.
Sue me, right? So I love the amp 16. The amp 16 has got 2 really big power supplies in it.
Yes.
But there's a really important thing that the amp 16 does that means I probably wouldn't ever recommend you buy one to drive it from a Denon AVR, right? Use the pre-outs on a Denon AVR into an amp 16, right? So that would be a bad decision.
Yeah, a little bit.
Because the amp 16, I'm going to get the numbers wrong now, and I should know the numbers. I haven't prepped. I was cleaning my patio, guys. It's bank holiday. I haven't prepped, right? The amp 16 does not have a huge amount of gain.
No.
Right. For its amount of output,
I can tell you what it is.
It doesn't have a huge amount of gain. And the reason for this is an amp 16 is designed as a paired system with generally with an altitude 32. It's a dB25 input. So you do a dB25 to dB25. It's designed as a paired system. Now, the output voltage that a Trinov processor puts out is higher than what many other processors put out. So
it's actually quite a bit higher.
Right. Typical is what, 1.4 volts on a AVR pre-out, I think.
It's probably specified on that spec sheet you were reading earlier.
Yeah, okay. Inputs, outputs. Does it tell me on that one?
If not, Amir probably measured it.
Sure. Off the top of my head, and again, I should know these numbers, but I haven't looked them up or checked them. The altitude's input stage to drive it to full power is expecting over 6 volts of input. These things are measured in, we do them in dBs. It's in dBu, or like you wouldn't generally measure it in, well, you can do it in these volts. But if you buy an amp 16 and you put it with a general AVR that can only output a small voltage and it's not adding a huge amount of gain, you can't use all of its power. You run out of input voltage way, way, way before you ever push that amplifier loud. They've done that on purpose because it creates a really low noise floor. They can have a very low noise output from the altitude. They magnify that by not a lot, and they keep a low noise signal path. Like the opposite would be if you put another amp with an altitude 16 that is driven to full power at 1.4 volts, then now what you've got to do is you've got to turn the altitude outputs way down. You're only using a fraction of what it's capable of. And then you multiply that out loads. And the self noise in that amplifier is probably, because you've got some gain, let's say you've got 29 dB of gain in that amp, the likelihood is you might induce in a sensitive speaker some hiss. So you need to make sure that you're matching the output capabilities of your processor to the input requirements of your power amp and actually checking that gain staging. I think very few people look at it and then end up in a position where they've spec'd a product that doesn't necessarily pair well.
I agree with that. I had something that I was going to talk about and I lost it. What was I going to talk about? You ruined me. Was it anything about the Denons? I don't think so. I think we already talked about this.
Did you just name what we were quoting?
No. Maybe. But it doesn't matter. It doesn't mean that they're bad. It just means that you need to use things within the realm of their capability. That's all.
Right.
And that chasing things based on a menial increase in output is kind of worthless, especially at those levels. It's not, you need a doubling of power to gain 3 dB. And if you're only gaining 20 watts, 100 versus 120, or it's not perfectly accurate, but just as an example, you're not even gaining a full dB.
Right.
So you got to make sure you know what you're looking at and what that increase, whatever it may be, is going to actually do and what you're going to net.
Yeah. And this is where it's hard, isn't it? So it's like this car analogy where we started, right? So you could add more power, which is like adding, more amplifier power. Those 10 watts you've added, great. But speaker sensitivity is, the car equivalent of stripping weight or improving aerodynamics. Once you've got a car up to 500 horsepower, do you keep adding more and more power, or do you make it slipperier and lighter to find the next speed gain? Probably those.
Well, it's like if you're on a drag strip and I have the choice between addressing aerodynamics or adding 5 horsepower. If I'm at 1,000 horsepower already, 5 horsepower is going to do virtually nothing. Right. The aerodynamics and weight savings, or let's say tires, may have a vast improvement depending on what you're doing. So you got to look at the correct thing depending on what level and how far you've pushed into that realm. What you need to look at can depend on how far you're pushing, on what's going to be the best choice for action. What would you say that for the average Joe an AVR is perfectly fine if you're listening at low to moderate levels for most use cases?
If it was in my own home, and I don't have a system in my home, but if I had one in my house, then I almost certainly would not need being a technical term here, I wouldn't need an amplifier because I live in a fairly small home with fairly small rooms with my kids directly asleep above. I don't have soundproofing in that home, right? So all things exactly as they stand in my home right now, if I put a multi-channel system in my living room, it would be pretty pointless for me to get an amplifier because I would be using like 10 watts per channel, if that, because I just wouldn't need it. So yes, I would say like a proper, real, normal home living room, like real world, how a lot of us live. Sure, I'm not saying amps pointless. I'm not saying they all sound the same. I'm saying when you're really not pushing them very hard, the money would be better spent elsewhere, right? That budget will be better spent on speakers or room treatment or soundproofing. Like there's a whole load of places to spend that money before you go into separates, which if you're on a low channel count, right? If you're only doing a 5 or a 7 channel system, to go into separates, you're like 10 times the cost because no one makes small 5-channel processors. Like you step up to a processor, you're probably going to a 13 or 15 channel processor at a minimum. No one makes a cheap standalone processor. So you either buy an AVR and then don't use any of its internal amps, right? Well, what are the expensive things on an AVR? Its power supply, that's the big bit that makes it heavy, and its output amplifiers. So buying one and using none of them, well, that's pretty pointless. Like, that's just not efficient use of money. So if you're a low channel count system, I'm going to say low as being anything under 11, so 7.1.4, and don't shoot me. I know how stupid that sounds. I live in a rarefied world, but anything under 714, I'll call a low channel count system. Below that, the disparity of cost benefit is even worse than it gets later, right? If you're already going for a 916, you either already need a top end AVR or a entry level pre-pro. The balance now has shifted a lot. Like, it's not massively different in price. You might be 50% more, maybe double, to do a 916 pre-pro against a top end processor. That, like, totally different world. If you're also going 916, you probably have a bigger room. Like, so there's a whole load of reasons. As channel count goes up, separates make sense. Under that, yeah, you probably don't need it. Or no, wrong choice of words. It's probably not an efficient use of funds.
Yeah, that's a better use. That's a better description. I think it's average use case for most people that are not chasing huge volumes, and most people aren't. There was a question in here from, or a statement more from E4 Superfly, saying that I watch movies at 75 to 80 dB with peaks at 85 to 93 dB. I don't know how you guys can watch any louder. And Superfly, this is not me saying that this is what's happening in your room. I think this is just what happens in a lot of people's rooms, is they think that is, and we talked about this at the beginning, they think this is really loud because there's a lot of distortion. And it's not necessarily the equipment. The room can add a ton of distortion from reflections and a load of other things. So people misequate distortion in a lot of cases for loudness, and it becomes uncomfortable. And I hear this all the time with spouses and partners. They'll say, well, my partner's system is way too loud. And my argument to that is, I don't think it's too loud. I think you're just encountering distortion. And if we remove the distortion, I think you're going to have an overall better experience with volume. And I always put this experiment on them. When you're in here for a demo, I'm just going to keep turning up the volume. And I want you to tell me when it's too loud. Nobody's ever told me that it's too loud. And we're push 120s, 130s. And it's not too loud. And that's because of the lesser distortion that is being misequated for SPL. Now, Superfly, I am not saying that is what's happening. I'm simply saying that is typically what occurs.
The trade-off with level there also being, in a typical family home, you have other family members' needs to consider, right? So
yes,
there is
he actually does say that at the volumes I watch at my family already thinks I'm nuts.
Right. So if they are trying to do other things in other rooms and you don't have a soundproof space, and I apologize for using soundproof because I'm the first to always say that that's a completely bullshit term. A well-isolated...
Yes.
Bullshit.
You're not stopping infrasonic wavelengths. It's,
right. If I go and throw a hand grenade outside your room, you're going to hear it, right? Trust me. If there's a war on, you're going to hear it. So it's not soundproof, is it? Right? Sound can get in. It's just...
We've helped is what's happened.
Right. So I shouldn't use soundproof because I'm the first to tell everyone it's bullshit. But
it is.
If you don't have a well noise isolated space, then you probably don't go louder because you know. And it's interesting, the things that play into psychoacoustics are so massive. One we didn't even include in the white paper, the CD white paper on reference level that covers a lot of the psychoacoustic factors, is the discomfort you get from the perception you might be annoying other people.
Oh,
right?
Yes.
We never, like, that was way beyond the scope of what we cover, but that is 100% a real thing. That you can't relax and watch a film loud if in the back of your mind you're constantly thinking, my neighbors are going to hear this, they're going to hate me, or the kids are trying to sleep, I should turn it down. Like
Anxiety.
that, you can't enjoy a film in that way. So
No.
even away from the audio quality, you're creating anxiety if you think you're listening louder than the people around you will appreciate. So, right, if you're in that situation, is buying a 1,000 watt per channel amp gonna be useful for you? Don't be stupid, right? You're already listening at a level that's suitable for you. If it's inside its standard operating range, great. So, but what is interesting is if you came and sat in Screen One at Foundry, or you went to, what's its official name? The Mad VR Experience Center, that's its name, right? And we listened with peaks at 93 dB, you'd probably be bored. Because
it'd be pretty quiet.
You would have just, there's so much more capability, almost certainly you turn it up, right? Because all of the things, the anxiety of upsetting people's gone, the distortion's gone, the capabilities are there. Do you know what? You like, your perception that we're mad listening at those levels would disappear real quick.
Caveat here. I think this does depend quite a bit on his house curve too, and what he's listening to, and what that measurement was taken at. Because if, depending on how that's weighted, subs and speaker wise, that could be pretty heavily skewed. 93 dB with just speakers with a neutral subwoofer, like not boosted at the low end, that could potentially be perceived as pretty loud.
Right. Yeah,
it's
sure.
not going to be inconsistent. So I think it, like you talked about with the AVR testing, the speaker testing, when you do these ABX testings, it's so important to have and note the variables. Like, I need to know, in order to really understand what's going on with that testing, what these variables are, so that I can equate that and look at it and say, oh, that's actually quite loud. If I have, or if I'm rolling the subs off quite early, or if I'm not using subs at all, you know, that could be your 95 dB. You're only 10. That's only minus 10, which is still not quiet.
Right.
And a lot of people may perceive that as quite loud, especially if, not saying it is, but if distortion's starting to creep in.
Right. You know, hey, I think I mentioned previously the room we've done with the outrageous amount of subwoofers and 5 black swans behind the screen. It's a big space. It will be listened to quite loud. Has the shallowest target curve I think we've ever done on a system, because at the levels that it's being used, it doesn't need a bigger target curve.
That's, remember, we talked about this with the Munson curve. The louder typically you listen, the less boost you need from the low end, and the more equal things are perceived. So if you're listening typically quite loudly, which I do, and I think you do at Foundry, our target curves are not that egregious.
No, really
they are there. There is a bump, but it's not nearly as egregious as it used to be when I was doing these systems many years ago.
Yeah. You know, there's a thing, right? You know, it's, if I see somebody with a 15 dB boost in their lower end, I know one of two things, right? Either they're not listening as loud as I listen, or they just really love bass and want to impress people. Like, you know, hey, if you're Scott Newby and you've got your 2424s, that's about bass, right? That the experience he's creating is intentional. It's not a ideal sound quality thing. Like, that is an intentional decision. Like people who want to move your hair in a car, right? You're making a decision for that much bass. But generally, if you've got this huge bass curve, you know, you're either doing it on purpose, or you're probably not listening that loud and you need it.
To be fair to Scott, though, having that many subs in the room is not a bad thing, right? It's going to help.
It is.
And he does not listen to movies like that. He just has a pursuit of what he wants to do. It's like the guys doing car audio with bass and stuff. I think it's what they're after. I think that's super cool. You've set a goal. You want to get to the goal, and you're doing it. And
100%.
people that say that that's wrong, dude.
I'm not saying it's wrong. You know, I'm saying
I know you're not, but I'm saying that's,
you know, if his hobby is the pursuit of absolute massive amounts of bass, then that's why you would listen loud and still have a big bass target curve. Like, because that's your pursuit. And I'm just saying, if I see somebody with a big boosted house curve, either you are intentionally chasing it, or you're probably not listening as loud as I do.
Or there's one more. You're trying to chase tactile feel without proper timing. You're substituting output timing.
I don't think Scott's doing that. I think he
No,
just has
not at all. I'm not saying that's what he's doing. I'm
Right.
saying that is another reason that you may see a big house curve is because I'm trying to get output because I'm trying to get this feel,
Right.
and there's something else going on in the room. I see
You're
that
trying
quite
to fix something that's lacking elsewhere.
Yes. Yeah.
Yeah.
Yeah. All right. Well, let's answer some of these questions because there are quite a few of them. If you have any more questions, whether they're pertaining to this topic or not, drop them in chat. We get to them in the order they come in. We always appreciate questions because we're huge nerds and we like talking about this and we find these questions interesting and it gives us something to argue about.
So if we start at the bottom, the best news today is that I think Steph's been out, so Tom's had to look after his kids, which means he's not been harassing us. So that's a good
He did
start.
harass me. He said, "Do messages while you're live streaming put you off?"
Yeah, but then he hasn't really sent any because I think he had children to look after.
Oh.
So
Well,
thank you, Steph, for giving us that gift today.
Poor Tom. Poor Tom. I don't feel this way about you, Tom.
I can assure you he'll play that back to Steph later and she'll agree.
Yeah. That's fair.
So we can move on from Tom.
Okay. Let me grab one. Derek Harrell 9116. Wouldn't these also be variables which could be tested like all scientific journeys? One test doesn't have to be the end. I think that's what we're saying.
Yeah.
It's just important to have the information so that you know what is being tested, but it's also important that we as people taking in this data look at things from a broader lens in order to broader may not be the right word. Yeah, maybe. But
I was just going to try and flick through a set of data. I just have it. I had one open on my other monitor, trying to think what stuff is kind of missing. So, what additional tests and variables might be useful? There are things like there are different intermodulation distortion tests that can be done. So, if you look at the tests that are done on the audio precision, they are, I think the technical term is they are steady state tests. I'm not an amp designer, right? So if I get this wrong, just correct me. There's probably somebody here who knows better than I do, so correct me. But they're steady state, right? You play a sine wave at a certain frequency, and then you can add another sine wave at another frequency. And look, when we're playing this 18K and this 19K tone, how do they affect each other? Where's the intermodulation? But they are sine wave tests. There are other tests you can do that look at dynamic intermodulation and transient intermodulation distortion. So one of them, as I understand it, and it's a while since I read the paper, it's ITU 60, 1, 2, oh God, I can't remember. Right. But you play a square wave and then a high frequency component. So you've got way more information going on. Like there is this big square wave happening, and now you've got your high frequency, and that now shows you what happens when there's like more dynamic swings. So you see additional stuff. So it's not that the intermodulation distortion test is wrong. It's just when we listen to music, that test does not represent what goes on in the film.
Square wave is
other tests that can be more representative of actual content.
Having a square wave, and correct me if I'm wrong, is effectively pushing an amplifier harder, and it may be a more real world circumstance because there's more going on than maybe one wave or two waves. So throwing in a square wave is saying, hey, we're going to stress this thing out. And it may be past the normal stress case, but I do like knowing what a piece of equipment's limits are so that as long as I'm using it within the bounds of those limits, I know I'm okay. Even if it's way below those limits, I know I'm not stressing that at all. My guidance for building a system and equipment is, especially subs, I want to be on cruise control. I don't want to be pushing things to their limits.
Understanding of the effect these tests have, I would be that, you have this feedback loop. So, the chip you put, a perfect amplifier would be linear, right? So you put in a signal and a bigger version, an identical but bigger, more magnitude version of that same signal comes out. But that's not what actually happens in a solid state chip. There is some distortion and there are things, there's noise and stuff that we don't want. So what actually happens is we take out the signal, and the chip is often like a fixed gain output, and it might be more gain than we're going to need later in the circuit. So you take out the signal, you then split it, and you take the signal back through a resistor to lower its level, back into the chip, inversed. So like we now have the inverse signal of what came out going back in. So it's a negative feedback. So any noise that's there has now come on your output signal, goes back round, a bit like a balanced cable. It goes back round really fast, out of polarity, and it now cancels out that noise. It also can lower the total output gain, right? So if the chip's giving us more gain than we want, we change that resistor in the negative feedback loop. That then changes how much we cancel the signal we did want. It can affect the gain coming through. And the more complex signals are more likely to show up problems in that feedback loop, things that deteriorate and change in that feedback loop that don't show up on a steady state sine wave, but would show up on a really complicated signal.
So to summarize what Ben is saying, we're not discrediting the validity or the importance of the test that is typically run. I think it's just also important to add tests that stress things further. And
Right.
Amir, if you ever watch this, you probably don't. Send us a message. Maybe there's a specific reason why you do this, or if anybody knows.
I think I have a suspicion. I'd have to dig it out, but I think Audio Precision themselves have a white paper that basically says these are the tests we do. There are other tests that we know that the system doesn't do that would show X, Y, and Z, but their hardware just doesn't have that capability to do that test, right? So the AP is the flagship piece of equipment for doing the testing, but I think they themselves know there are other tests that are valid that they don't do.
And this is exactly this. Derek then goes on to say, aren't the tests still valid? Yes, they are. Just not all the valid tests which are needed are shown. Yes, exactly. We need more data.
Like one of the things that would be interesting to see that I don't believe Amir shows at all, and it's a much lower resolution test, right? So you're not going to get the same amount of resolution of detail out of it. But if you run a square wave into an oscilloscope, I want to see how square that wave is.
Yep.
Because you might get some overshoot, you might have some ringing, you might see some slope to those squares, right? So actually, there are things that we could see in the time domain on a scope that don't show up when you just put a sine wave in.
Yep.
There's more info to see than the test we're currently getting.
Derek's full of great points. And this is actually, and I'm going to take this a little bit further than what Derek says with an actual example. So he says, in the same way a dyno can tell you how great info on the differences of how much power cars deliver, that won't necessarily show you how the power delivery affects the driving of the car. There's a great example of this, and that is air intakes. So the air intake that is an example of this is there's a JLT air intake for a 2020 through 2022 GT500. The air intake has an open top, which people really like. It does really, really well on power when you put it on a dyno. When cars are on the dyno, a lot of times, what configuration are they in? The hood's up. If the hood is up and the air intake is open on the top, you're going to get huge amounts of air. But that test is not necessarily informative of how the car will perform when it's driving. Hood's down, air's coming in a different way. They found, at least a couple members on these forums have found, that a different style air intake, in this specific example, one made by VMP that pulls air in from a different location, netted them like half a second on some of these straights that they were doing because of the amount of sustained power the car was able to generate from actual air being intake during a driving test instead of on a dyno. So while yes, the tests are representative of something like it being on a dyno, it is also very important to use the correct testing methodology to ensure that you're getting the correct data. Because if I take that data and I'm not considering all of the variables, in this case, the hood being up, where the air is coming in, ambient air temperatures, which I think that's being considered, and other things, you're going to come to a misleading conclusion. The conclusion is not necessarily wrong, but it's not giving you the information that you need for your particular application.
So I don't know the answer to this because hey, I buy a car and let someone else deal with it, and you seem to understand them and tune them and tweak them and change them and get your tools out right. Would you see turbo lag on a dyno test?
To a point.
Okay.
Sure. I'm not into that nitty-grittiness, so I'm sure the guys in the chat will know.
I would say like turbo lag is one of these things, right, where if you're measuring power under the right conditions, if you've already spooled the turbo up, then you see a certain oh, look how much power I've got. But when you're on the road and you're going 40 and you want to overtake someone, and the turbo has, you've now got to spool up and you've got a delay and you've got turbo lag. Hey, right. People crash Ferrari F40 still for a reason because turbo lag's a bitch if you're not expecting it. And that's kind of this same thing. I don't know if turbo lag shows up in these tests or not, but
regardless if it shows up in
how
the
much
test
power
or not,
you've got's not the only criteria. How it actually gets delivered in the real world is important.
Yes. I mean, Max, it is an important criteria, which you say, but it's not the only important one. Good point, Derek. Ryan B, 6763. What do you think about sealed versus ported mid-high range point source speakers? Ported subs cause phase issues. Do ported mids cause similar phase issues?
It depends. I would say that where that depends is at the crossover. So I quite often use subs and mains from the same brand where I know they've intentionally considered what that is going to be happening at that crossover.
Yep.
But yeah, that you need to consider it as part of your crossover design. And it's one of those things I quite like about higher end processors, that you have got control of that crossover. So in an AVR, it's going to be quite straightforward. You set the frequency and it will be symmetrical, right? You set it at 80 hertz. It will be putting a LR4 both sides, a 24 dB per octave roll off both sides. That's just what it's going to do, right? It's a symmetrical LR4 done. You've got no fine control over that. You can't make it asymmetrical necessarily. You can't change the slope. There's very few reasons why you'd want to normally, but this might be one where you're moving from a ported main to a non-ported sub, and actually you might want some control over that transition.
Yep. It does. So I use ported mains and ported surround. All of my speakers are ported in my theater. It's a compromise. I think ports are a compromise. You're using the port in order to gain more low-end output, right? As we roll down, you're going to gain the as the port takes over, it's just more efficient and you're going to gain more output. It is a compromise though, because we're introducing these variables into the time domain. And I am okay with that compromise. The important thing is knowing that that compromise exists and how it is going to interact with your system. And then making sure that you have the tools to deal with that. What I would tell people not to do is to have a bunch of different speakers that have different port tunes, just like we do with subs. You're introducing anomalies that you don't want to deal with. It's the same thing. The important thing is to know that this is going to happen and then make sure that you have the tools to deal with those issues, not really issues, but those things as they come up. And Storm and Tronov and high-end other-end high-end processors, and their abilities with filters allow them to deal with those anomalies as they come up. You have the control to deal with it. I like that granularity. Not saying something like a Denon or a Marantz or an Anki or a Yamaha, you wouldn't have a great experience. I just like having the granular control. Okay, good question. And that's something a lot of people don't think about. Brian Cobb, how much power at 4 ohms do you like to have on the Perlisten S7 speakers to have plenty of headroom and large room to hit over reference level, 6 meter wide by 8.3 meters long by 2.5 meters high? Any favorite amps?
All of it. All of the power.
Yes.
I want all the power. I want to be plugged into a power station. I love, right, so I'll be honest, I love S7s. There is a reason we don't put them in the big rooms that we build.
You run out of gas.
We have Perlisten here in our smaller room upstairs. If I was building a system at home, it would almost certainly be Perlistens. I absolutely adore Perlisten speakers. I think they're incredible. Again, my brand neutrality just pissed right off. It's fine, right? I'm not going to lie. I think they're incredible. There is a point where they become challenging in a really big room. And 6 meters wide, 8.3 long is certainly verging on big. It's not huge, but it's not small. They need all the power.
Now, a big part of that is going to depend on, I know where Brian's seated. It depends on the seating position too,
right,
and how far we're trying to throw the sound, because every doubling of distance, anechoically, you're losing 6 dB. And we're not accounting for room reflections and gain, boundary gain and all that stuff. But anechoically, you're going to lose 6 dB for every doubling of distance. So something to consider. I think it just depends on how much, I'm going to say this quite frankly, how much money you want to throw at it. Because to get good amps that are going to deliver that amount of power for that many channels, it gets expensive.
Yeah. So I probably would, it may be Brian I've spoken to once before who raised this question online somewhere. I answered. I don't know if it is or not. I don't recall, but I remember having a discussion with someone online who had a requirement of the amps I'm running are clipping into a pair of S7s. And in the rooms I put them in, a bridged output from an amp 16 is generally enough power. And I wouldn't have problem bridging outputs from an amp 16 into them. If you're getting to the point where
now that's
bridged outputs from an amp 16 is not enough, then you just need all the power.
That's 400 watts, correct?
No. Oh, hold on. Let me check.
Or is it
one channel bridged 4 ohm is 1,000 watts at 0.1% distortion.
Then that you're exceeding what that speaker is capable of handling.
Right, but that is at 1 kilohertz at right. So sure, does it really do that everywhere? You can't then load that amp 16 up like that everywhere. No. Like if you've only got 3 S7s or screen channels, fine. But
no.
Like we've got points,
way more than that.
We've got jobs where we use bridged amp 16s for every single channel, right? So I run 8 bridged speakers off it, but I wouldn't necessarily do that if 3 of those are the LCR. I'll have an LCR and then I'm happy for my surrounds in a very big room to be bridged outputs from amp 16. But in the same way I talked about with the AVR, the power supply is still going to at some stage run out of room. So if you're running 230 volts, which if you're running an amp 16 and you're not running 230 volts, then sort your life out, call your electrician, fix your life, because
you're leaving a lot of capability on the table.
I'm pretty confident that Brian would not be running amp 16.
And frankly, the other part of that, even if your amplifier can handle the amount of power on a 15 amp circuit, it's just going to run cooler on a higher voltage capable circuit.
And bridged, right? So bridged, it's only 22 dB of gain. So this absolutely relies on you having enough input voltage to feed it with. If you're taking a typical Denon and throwing an amp 16
he's got enough input voltage.
Fine. So I like the Amp 16. If you need more output than an Amp 16 bridged is delivering, the answer is maybe the S7s weren't the right speaker for that room, and that's really hard because they're absolutely wonderful speakers. But if you're like, there isn't much more power than that's clean, that's got good transient response. It's hard.
Brian, Amp 16 is Chernoff. The Storm's has a similar amplifier, the PA 16, and they actually have a new one that just came out. I can't remember the name of it. It's a 8-channel that they've increased the power supplies and some other things on. We can talk about that offline if you want to get together today, because you and I have been talking about some stuff. And the nice thing about matching those, right? If you use a Chernoff preamp and a Chernoff amplifier and vice versa, they're gain matched. I mean, they've done that intentionally in order to minimize noise floor and other situations. So there is a reason why companies like Storm and Chernoff publish those statistics and line items in their spec sheets, is because they've done it intentionally.
Yeah.
Good question. So we did that one. Palindrome guy, with TVs getting bigger and cheaper, but center channels really being the weak point due to the horizontal aspect, can we have expert opinions on a 4-1, i.e. a wide dispersion, better experience? I think you're fine as long as you only care about the main seating position, doing a 4-1. Phantom center, I don't think you'd have any issues doing that. Do you?
Right. No, I like Phantom center for single position. I think can work really well. If you get left and right beautifully well set up and get a great stereo image, it falls apart real quick if you've got multiple viewers.
Yeah.
So if there's 3 of you, might get away with it. By 5 across that row, starting to be a challenge. If you've got odd shaped or living room style seating, you've got a couple of seats that are off to the side, it falls apart real quick.
The other place that it may fall apart that a lot of people don't consider is you're asking more of your left and rights when you're having them do the center too. You're going to increase their SPL output when you do this.
Yeah.
And you're going to push them potentially quicker to their limits. So if you like loud, you may want to look at something else. There are speakers that do this quite well. And I'm kind of over the not talking about brands, especially for companies that do this well. You know, if you do something like an Ascendo the 10 and do a point source speaker that's at the center, you don't really have issues with this. And they make horizontal versions. So this is where specific driver types can do very well in different situations. In something like a coaxial for a center channel, there are worse decisions that could be made.
I would say actually the optimum solution when you only care about one seating position is quite challenging, because each of the solutions have got different problems across bigger seating areas, right? So if you only care about one position, over under, you can get perfect to one seat. Like, you're just phantoming into center separately, and you're taking the load off the left and right. You're reducing that SPL capability. You can still make that work really well.
When you say
all
over
of these
you
things,
mean a bottom and top center channel?
Yeah.
And I actually quite like that solution.
Right. I like it for a small listening window. I think it can work for one row. Like, it falls apart over distance.
Yes. That allows you to handle multiple seats as long as they're on one row.
Right.
When you start getting into multiple rows and you're dealing with different distance and where the convergence for those speakers, where they come together, then you can start running into problems. But if you're one row, like a lot of people are, I really like that solution. And some purists are going to be, but the comb filtering.
Right. But at one row, let's say they're coaxial speakers above and below.
Yep.
Not a typical big MTM center channel, but you take a small, thin coaxial, like you said, right?
Yep.
And you put one above and below, then actually the time of arrival to each seat is kind of the same, right? So comb filtering, you can deal with it in your calibration
Yep.
when you're doing your time alignment and your EQ.
And it is a compromise. It is not a perfect solution. If you're trying to eliminate all variables and be like, this is not perfect, it is not perfect. But if you put just a center below, or you don't have a center, you're compromising in other ways. And the other advantage that you gain, I'm going to kind of put Ascendo on a pedestal here, is they actually design speakers for this exact application. Like the what is it? I forget what it's called. The 10 is it the LCR, or it's the LED wall or some, I don't remember what he calls it, but it's on a 10-degree or some minimal wedge so that it's angled for exactly this purpose.
Yeah, and
above and below
God, do they
LED
play
walls.
loud, don't they? What was it called? The one they launched at ISE?
No.
Oh, the 10, oh, no, okay. So
This
probably
one's
not
been
the
out
one
for
at
a
ISE.
while.
The 10 passive LED Phantom.
Yes, the LED Phantom. It's the 10, exactly the same. It's just in a different cabinet that has a slight angle on it so that you can put it above and below. You could put a normal one below and an angled one up top. It just gives you variable, and it's designed for this application. So I like the over-under.
Which isn't what they played at ISE, right?
No, that's a different speaker. I don't
Yeah, I
remember
can't
what
find
that
that on their
one's
website
called.
now.
I don't remember what that one's called.
It was a 6 something, because it was quite bespoke, wasn't it?
I thought it was an 8.
Maybe it was an 8, you're right.
I think it was an 8.
But it was more along the lines of the Halo. It was a serious, beefed up, huge.
I think it used the same tweeter or something that the Halo had. It was, yeah, a little more bougie.
Yeah, 10 passive LED Phantom. Yeah, cool.
Solid speaker, and I think that would
accomplish
what you're trying to do. But 4-1 for a single seat, as long as you're within the realm and capabilities of those speakers, not a bad solution at all. Pound Drum Guy asked another question. Thoughts on pro subwoofers for someone who loves mid-bass punch? I can get a good deal on the JBL ASB 7118. How you feel about pro subs?
I don't know if I've ever heard that. I mean, I may have heard it in a commercial environment. I almost certainly have never heard it in a small room. Indifferent.
I don't think it would be bad. I mean, pro subs are designed for one. There's probably other variables, but I'm going to use this as, I'm going to be kind of over the top on this. One important reason, and that is mid-bass. It's what they do. Big rooms, lots of mid-bass. They want to give people the tactile feel, and they do it very well. Big drivers, fast drivers, light drivers, they do it very, very well. I've never used that sub, but you're using it for what it's designed to do, theoretically.
Yeah, I'm just Googling it now. I mean, it's rated down to 25 hertz, so it's not like it falls off a cliff early.
But what does it mean when it says rated?
Oh, no. Okay, so system, you've got maximum SPL, you've got system sensitivity is given. So it's frequency range. Oh, okay, no, okay, right. That I read the wrong line. Maximum SPL 1 meter, 25 hertz to 200 hertz is given as a figure, 129 dB. Its frequency response, its minus 10 dB point is 22 hertz. Its F3 is 34 hertz. Okay, so that as an F3 is higher than I'd like.
But for what he's using it for,
sure,
you get a good experience with that. I think. I've never used it, but based on
not everybody needs or wants really low end, right? I do need and want it, but I mean, hey, right? Say you can get a good deal on them. Can you take a couple home and play with them?
Yeah, and you know what also comes with not having the super low end? It's easier to isolate. Easier to isolate the sound. You're not having to deal with traversals of those lower wavelengths, and it's easier to deal with.
Yeah.
So if you can get a good deal on them, I don't see necessarily a problem with them as long as they integrate with your system well. Derek Harrell, has CEDIA defined what is needed from amplifier receiver manufacturers to be able to compare them more directly, like what we've talked about with speakers in RP1?
Yeah, I actually have it open on my desktop now. So it will be called RP1. The first two parts of RP1 that we published are speakers and amplifiers. They have gone out for peer review, and the peer review feedback is currently being analyzed, discussed, included, excluded, however. So they are going. The first two parts, speakers and amps, are in their peer review process. They are. I'm not going to tell you all the things on it because they are under peer review and they're not final. But there is a lot more than we would see on a typical data sheet, right? A lot more. I'm looking down the spreadsheet and it runs to 45 individual parameters, I think, that are asked for. It's going to be a lot, right? And each one of those parameters will be defined really carefully. So it's going to be we want to know this output parameter, be it a voltage, whatever, right? And we want it to be defined having been measured on this specific test. We want it presented in this specific way. So once manufacturers give data that, I don't know what the technical term will be, I'm going to call it RP1 compliant, but if they give us data which matches what RP1 requests, then every manufacturer that gives you that data, you know they've done the same test using the same methodology. They're giving you the same data for every line. So then you can directly compare, this one can do that, this one can do that. You know it's the same test conducted in the same way. I don't know how much longer the peer review is. I've not made an RP1 call for a few weeks. But I would hope it will be Expo this year. So that's October, right? September? October? September. Yeah.
Beginning of September, August.
So yeah, it's imminent for those categories. There will be loads of additional categories done. They will follow as they're ready. This ties up the whole thing CD are doing in standards. So we already did RP22, which is how to design a system. RP1 now means when you're doing RP22, you've got the data you need to do the maths in RP22. And then Adam Pels and I currently chair RP32, which is, right, you've built a room, now measure it and prove it did what you thought it would do. So we're closing this loop, right? Design is done. We need to still get correct data to input, and then we need correct measurement on the output. And there will be additional bits in between. Video will follow that same process, right? So there'll be an RP1 equivalent for video. There will be RP23, which is the video design. Then there will be an RP33, which is measurement and verification of video installed. Right, it's coming. We're a small group of standards volunteers, so we just do it as quick as we can.
Good question. Mike Stevens, 2397. Question on Class D modules being used to manufacture amps. Chernoff Marantz are using Ice Edge modules, and some amps offer Hypex or Purify modules. Is this cost of longevity choice on the part of Marantz, Chernoff, and others, or do you have any listening experience between the three, even adding Pascal modules to the discussion? I think the question is, why are they using different modules?
I would guess some of those probably predate others.
They do.
AMP 16 probably predates Hypex.
It does.
Being available, I guess. I'm less focused, right? I've seen Hypex measurements, right? I understand how well they measure. Wonderful. But for me, the choice of module isn't the biggest end game. It's everything around it, how well it's been implemented. I have seen amps. I can't even remember who made it now, but somebody using, like this top of the range Hypex. Is it like Hypex 500? But one of the top end Hypex, and they put multiple of them in a chassis with a power supply that absolutely can't sustain multiple of them to their true capabilities. So it's like you can take the best module and not use it very well. So I'm more interested in what the system designer has done to make sure that they've built something that works for its purpose, and that you can't just tell that from, right, they've used this module or that one. So I couldn't tell you why any designer chooses one over another. the likelihood is that decision might be different now than if it was 5 years ago, or like difference in production life cycles. But there's like how big and how good the power supply is, like how can that sustain transients? Like that's one of the differences. We've talked about the old Ascendo 10K amp against the new 10K infrasonic is how
wildly.
long can that power supply sustain this output, right? If one of them could sustain it for, I think the test requires it to do like 40 milliseconds, right? It's a kick drum type impact. It's great for music, right? So it can sustain it short term, then it recharges and it can sustain the next one. Against an infrasonic that might last 2 seconds. Completely different requirements on the power supply. So just judging which module we used is kind of irrelevant without also considering how the power supply has been built, how it's all regulated, how it like there's loads more to it.
Yeah. And like I said at the very beginning of this, don't look at everything individually, though that's a good way to start. You need to look at everything together as a sum of its parts to see what the actual outcome is. Because you may get parts that are substandard, not saying any of those are, but when they work together, you may have an excellent result that is exactly what you need. And the result is what you're after, and making sure that that result meets all of your expectations, whatever they may be. Some of its parts, that's how we need to look at things. Is it delivering what we're asking of it, regardless of what it's made up of, what amplifier modules, all of that? I think they can all be good for different reasons. They all excel. I think a big reason is, like Ben alluded to, with when the Amplitude 16 was designed and manufactured originally in comparison to when Purified and HyperX came out. They may have decided to change if it was later. I don't know. There may be some type of capability that the Pascal or ICE modules have that the other ones don't, that I'm not privy to. So the key, though, is what is the result?
Right.
And the result is that the Amplitude 16 does very well at what it's been designed to do and what you're asking of it.
Yeah, I don't know how the other modules would fit the gain structure that they've chosen with the higher input voltage against a lower gain stage in that. Like, I don't know. So we have loads of analogies. Car ones are used the most, but I think one of my favorite analogies that I haven't used much on this podcast is about us being chefs. So,
sorry, Peter.
Yeah, well, Peter and I think Peter actually attributes this one to me. So most of them, all the car ones are Peter's, 100%. But the chef thing is interesting. So our role as an AV designer is to use the ingredients we've got the best we can. I don't design individual components. I'm not too concerned about how each individual component has been put together. I trust the manufacturers I work with to have taken the right decisions. In the same way a chef goes out and gets the best beef and the best vegetables, but most chefs aren't raising their own beef, right? They haven't got their own cattle farms because they trust their suppliers downstream. So we want to use the ingredients the very best we can and trust the people in the rest of that supply chain to be doing the best they can. I'm not a transducer designer. I'm not a speaker designer. I'm not an amplifier designer, right? I need to work with people who have created the products that are suitable for what we're going to do and not second guess their decisions, right? They know why they made that decision. And if the totality of that product works for what I need, great. If it doesn't, pick a different one. Don't beat them up for making a decision that doesn't suit what I wanted.
Sorry, dealing
to
with
act like a
some AVR
chef.
stuff. Good questions so far. Keep going. CSO. What would be a good curve on low end if someone likes to watch movies at 10 dB? There's a negative 10. There's a lot of variables that go into that.
Yeah.
You got a good example, though?
I don't have a Fletcher-Munson curve in front of me, but in theory, you could look at the Fletcher-Munson equal loudness curves, drop 10 FON, and look at how much a difference in hearing sensitivity changes down at that lower end, and look like you could base your curve on that. It depends, right? Because it depends what the subs are capable of. It depends. So like there's loads of variables, but it's certainly going to be a bit more boost than if you weren't watching at listening at -10.
Mm-hmm.
A couple of dB more than I would probably have on one of our systems. If the system is capable of it, because boosting it into a point where it's not capable is going to sound terrible.
I would just do to what your subjective expectation is. How much do you want? Everybody's a little bit different. I think the higher you go, the more neutral it's going to be. But just start somewhere and see if you like it, and then start deviating. Important thing to realize here, though, is that if you're just playing with gains on the subwoofers, you are impacting your crossover. And you're going to start pushing your speaker levels or your low-end male vocal levels up further, because you're going to start pushing the gain up. And remember, it's not just a hard brick wall. You have this curve, and the curve was calculated at X gain. So if we start increasing the gain of the subwoofers after all of that calculation, well, now, even though you're just rating the subwoofers because they're playing together and coming in with one another, well, now this is coming up and your curve is pushing further and further and further and further out. So that's going to impact more and more and more and more into the upper end of the speaker range, especially things like male vocal, lower end female vocal, things of that nature. So just something to consider. And this is why people will constantly rerun the auto EQ on things like Dirac or Optimizer. Optimizer is a little bit easier because you can just play with it and then it'll recalculate it. But that's why they rerun these, so that when they're playing with their house curve, instead of just adjusting the gain and setting it, the auto EQ will fully adjust everything instead of playing with it afterwards. A lot of people don't consider that, and it can get them into trouble. Cyclone CGS, thoughts on the Stream controller that's releasing today? Seems like a great tool for home theater PC gaming. I know nothing about it.
No, nothing about it.
So probably good. I know it was delayed a lot because of component shortages, but we are not the channel to ask about that, Cyclone.
You used to be like a proper gamer nerd, though, right?
Maybe.
Is that offensive to say gamer nerd? I know nothing about gaming culture at all.
No, it's just the game. I was sim. So when I'm doing it, the combat flight sim, which is sitting behind me, it was all about, it's like playing 4-dimensional chess, right? I'm having to deal with aerodynamics and speed and weapons profiles and all different kinds of stuff, where there's a lot more math involved in what I was doing. It's not your typical reaction-based gaming. Not that that's bad. It's just I did something different, and I ran a lot of competitions. But yeah, I was more into it. I need to get back into it. My buddy and I think we're going to get into sim racing. I don't even know if I need another addiction, but it's happening. So we'll see where we go. Macro proxy, what are the downsides of a room wider than deep? Assume one row might change to a room about 14 by 18 by 20. Dang, I like his ceiling height. And would like a bigger screen wall than 14 foot. I have the Epson QL, so throw is workable.
I mean, downside is interesting. I've built rooms exactly this way, where the geometry did not work for viewing distance versus screen width when we looked at it the other way around. So I've got rooms, like I've won awards for rooms, in fact, but we did exactly that. We took what the architect had designed and just let's turn it round. Mm-hmm. I think we ended up with 6 seats wide, which was most of the room. A short distance to the screen. We managed to make throw distance work with the use of an anamorphic lens. It became quite tricky because it was a really small room, but I think it can really work. The big downside is that you're going to get bigger seat-to-seat variance as you go wider. So you're going to calibrate your surround level for the middle of that room. And as that row now gets wider, right? So where you may have done 2 rows of 4, like I haven't worked these numbers out, right? So how wide this is, but let's say you did 1 row of 8 instead of 2 rows of 4. The people sat at the end of that row are now really close to a surround speaker and miles away from the one the other side. Their variance in SPL level is ginormous, and that is a factor of physics by making a wide room and being close to one surround, not close to another one. So it doesn't have a hugely detrimental effect on the two people in the very middle. But as you start to move out, you will get a radically different surround effect.
Yeah.
You get different issues in a long, if you've gone long and thin.
It's a compromise, right?
Yeah.
Which way are you going to choose and which issues you're going to deal with? That's what it comes down to.
But if you typically, like, so here's where this works for me and why we chose to do it in the use case we did when we did it in this small room before, is if the room is typically going to be used by a small number of people, right? We all love building rooms with loads of seats that cater for the once in a, oh, it's Super Bowl Sunday, I have all my friends coming around, the one day of the year that you invite your friends around to watch them, right? The rest of the time it's you and your partner and one or two kids, right? And it's 1 to 4 people. So if it's 1 to 4 people using it, that listening area is compact enough that it could be great. And if you can't get the screen size you want and the view, like if you can't make the viewing geometry work on the narrow side, flip it round, make the viewing geometry work for like 2 to 4 people. This width thing, great. And actually, for 2 to 4 people, what happens by going wider is you actually improve the seat-to-seat consistency of SPL across your surrounds, because
they're further away.
The propagation ratio improves, right? You've now got a bigger distance before the first one hears it. It actually improves the ratio. So like you actually get a benefit. It's then where it gets worse, right? When people start now getting close to a speaker. So
the ratio that Ben's talking about is the loss of 6 dB over every doubling of distance. As you're further away, that doubling takes place over a longer distance.
Right.
So it's 1 to 2 meters, 2 to 4, 4 to 8. And as you move further away, right, the sound is going to dissipate less over that distance, and your seat-to-seat consistency improves,
right.
which is a big reason why big rooms have an advantage. Their seat-to-seat consistency is far greater because of that variable and how sound propagates.
The follow-up point that's just been made is it's going to be a 13-foot wide couch either way. So if the seating remains exactly the same, you are going to actually get a benefit to your surround by turning it that way. That's normally like where the first limitation runs out. So when we look
as long as the surround can throw the sound that distance.
100%, right? So that is a downside, is you may need, but we're only talking about 14 by 18. So it's not like it's radically.
Yeah, but it is something to consider, because you are going to ask more of it. And if you're already on the fringes, you could induce something.
Yep. So if it was me, I would draw both up and I would do some math and engineering on how they both work. Like without drawing them both up in details, I wouldn't be able to say, right, this is better, that's worse. But with those room dimensions and a fixed 13-foot wide sofa, right, 13-foot wide sofa in a 14-foot wide room is a shit show. It's a shit show. Like, let's not get around it. Somebody is right next to a speaker. 13-foot wide and 18-foot room, at least you've got a fighting chance.
Yeah.
So I already think I'm with you on turning this room around.
The other things to consider are door location, which can be a huge part of this that a lot of people don't consider. There are very few optimal locations for doors with speaker locations and how they impact things. My favorite is between a front wide and your side surround. Or you could put it smack dab in the middle, depending. There's not as many as people would think. So door location, acoustic treatment possibilities, depending on the room geometry, is a big one. We're not really concerned about throw distance, but projector location could be part of this. The QL is not overtly loud. It's actually very quiet, but its heat output could be something to consider. Subwoofers is going to be a big one. The distance that they are, where they can go aesthetically or geometry wise, height of the screen, because you say you're 9-foot ceiling height. So there's other variables outside of just the simple ones that you're considering. And I like Ben's approach of, you got to draw it out and you got to start listing the compromises of what issues am I going to run into if I do the room this way versus the other one. And then Venn diagram it and compare it and look at it and say, which compromises am I okay dealing with? Because there's going to be some in both scenarios. Which ones am I okay dealing with? And then make your decision. But at least make an informed, objective decision, having all of that data instead of basing it on, not saying you are, on one variable. There's so many variables and so many things to consider that you got to draw it out.
Yeah.
Bill Kravosky, 25 by 17 by 10 room, Perlison S all the way around, Denon A1H Chernov soon. Thoughts?
Well,
that's a big room.
So I've never used an A1H, I don't think, but I do have one open on my screen.
So the A1H is the big boy Denon AVR. It is, even though it is an excellent AVR, it's not going to have enough power for those Perlisons. So in terms of power consumption, right, this thing now can pull 1100 watts. It's double the size of the one I looked at earlier, right? So it is a big power supply. She got a badonk-donk.
Right. But take that 1100 watts is its maximum draw. Okay, considering that is putting, how many channels is that amplified to? What does that 15. Thing do? 15 channels. Okay, right. So it's 1100 watts over 15 channels. If I compare that to a Trinnov amplitude 16, an amplitude 16's maximum power consumption is
4 or something.
Total output power on a 230 volt is 3,200 watts of output.
Yeah.
Its actual power supply,
regardless,
power consumption 2 times 2,000 watts.
Regardless,
so it's 4 times as much power.
That 1100 watts on that A1H will be eaten by one S7. Half of that will be eaten by one S7i.
Yeah.
If you're playing at its maximum capability.
Yeah, so this is where you start to realize where these power numbers come in. Like an amplitude 16 can pull from the wall 4 times as much power, right? And where these things, right? So one of the things that I don't think AMI's tests show, and I might be wrong, because correct me if I'm wrong here, but I like to know what happens when things are getting bad, right? So if we are in a position where the amp is being overdriven or it clips, how quickly does it recover from that? How quickly does it recover from a massive transient that absolutely blows it out and pushes it to its limit? How quick does it get back into its low distortion, great operating range? And if you are pushing that sooner because you're running out of power, so you suddenly become current limited and the whole thing starts to sag, then you're going to sag. And how quickly does it recover against taking an amplifier that can sustain 4 times as much power input, right? I know that's only just over 3 dB more output as such when we look at it that way, but the likelihood is you're going to push it harder before it gets into trouble. And in a big room, because that's not a small room at all, right? In a big room with S series, I'm going to say they deserve separates. And I'm saying that having never heard an A1H or...
I don't think it's that they deserve. I think they kind of require it with how big that room is.
Yeah.
An integrate is just not going to have the power to be able to do it. It's not. So you need separates.
What is the power handling on a 7?
700 watts, I think.
Yeah, I don't know if it's... I presume these are S7s at the front. It says S series all round.
S7Is.
They are. But let's take an S. I've got an S7T on screen. It's what I've just opened up. Hold on. Tech specs. They take a lot of power, right? Or they can accept a lot of power. I thought it was 800 watts. Recommended amplifier power for an S7T is up to 600 watts RMS. Okay, 600 watts RMS output. The Denon power output 20 to 20, 0.05% distortion, 2 channels driven, 150 watts, right? Those Perlisons can accept so much more than the Denon can sustainably give you. And at these size room, they need it. you're going to be throwing like high distortion power at them that limits, but you're basically strangling them. Is the truth.
Yeah.
Right.
Especially
And you've
if you're pushing to the limit, you're going to be running out of gas. If you're not, like we talked about at the very beginning, not a problem. Still excellent speakers, but if you're asking a lot of them,
now if you had that much power and you were using Ascendo 10s, right, relative to your spend, you've got loads of power, you've got a more sensitive speaker, you're happy, right? You're flying off to the races. But in this case, S7s, not cheap. You've spent a lot of cash on some incredible speakers.
They are amazing speakers. Yes.
Right? Then I've just seen the price of this Denon, right? It's a lot of cash, right? There's no getting around the fact in AVR world, that's maybe the second most expensive AVR I know of, right? That's absolute top draw. It's not a Storm Fusion, I guess, right? Which is a lot more money, I guess, again, but
it's also a lot more power from the Storm Fusion.
Right. So even though that is as good as AVRs come in that mainstream world, those per-listens need, in a room that big, they need more power.
It's not the level that you've established for that theater. The S7s have established a level, and they require, it's like dealing with a pro athlete, right? You trying to get to a certain level, you got to feed it what it needs to get the output that it's trying to obtain.
Except for Usain Bolt, who the day of the Olympics was eating McDonald's chicken nuggets because he didn't want to risk Chinese food, right? But
that's fair.
But I'm sure he didn't train on those for the whole season. The other thing I would say, depending on where you are, if you're based in the US, make sure you're running 230 volts.
Hey, that's the next question.
Right.
Derek Carroll, on the topic of voltage, I've heard folks suggest the idea released recently to build out a dedicated theater in the U.S. with all equipment set up and running 220 to 240. Hell yeah.
Right. I mean, so you guys maybe wouldn't have kicked the Brits out if you could, enjoy drinking more tea. There's a reason that we have electric kettles and you don't. You don't have enough power. You don't have enough power to boil water. You definitely don't have enough power for big subwoofers. Do you have an electric kettle?
Not an electric kettle, but we can boil water on the stove, but it's on 240. Haha.
Sure. But every house in the UK has an electric kettle.
Yeah.
You try running an electric kettle at 110, you never get a cup of tea. It's never ready.
You could if you gave it enough current, but you're going to trip the brake. The breaker's going to run out of gas.
And these are, when we start talking about big amplifiers and lots of subs, you're going to want 240 circuits.
No joke. Even if you're getting the same output, right? Let's say the amplifier can't get to the level that you're needing. You're going to trip a 15 amp breaker. The benefit of running, correct me if I'm wrong here, Ben, the benefit of running 240 over 15 is it's cooler. It's not, you're exchanging volts for amps.
Right.
So,
and it's the likelihood is that, especially if it's a non-dedicated circuit, right? So if you are on a regular 110 and you're running multiple pieces of kit from that, including, in the last case, that big A1H or, big power amps, the Amplitude 16 needs 2 inputs, right? It's got 2 plugs to the wall. It's basically 2 8-channel amps in one box.
Yep.
So you're not running that off 2 plugs on a 110 circuit. It's not going to work. So I would want we don't have a problem here, and we do a lot of work around the world. When we're working in the US, we require, but it's a 230 volt. Yep. It's just it's a given, right? It's just not a flexibility thing.
240, baby. It's what I always recommend to people. You're building a new space, just do 240.
Yeah.
It's way easier. You're putting the breakers in anyway. Most stuff is auto switching now. It doesn't care. It's just going to be better. Yeah, thanks, Superfly. I'm on Team Kettle. Okay? I don't even use kettles, and we're on the same page. So it's not bad. We're in agreement. Kelderek 4627. I have a nasty hum on my subs in my new home theater. It fluctuates when I adjust the dimmer for my lights. Am I right to think that this is RF interference and DC offset surge protector might help fix it?
There's a couple of things that could be at play. I don't know even what country that's in, how that lighting's done. Like, I don't know whether there is an earth connection to that dimmer. Like, there's a whole load of things where you could be getting that hum. It's not as straightforward as just saying it's RF, because I don't know what kind of dimmer it is.
The odds that it's a dimmer.
Right. I mean, the thing is, right, so dimmers generally, if it be a leading edge or a trailing edge dimmer, right, they are intentionally cutting off the waveform, right? So you've got the waveform and they're basically using, like, there's different ways. It could be pulse width modulation. They're doing things to reduce that power. They do often have the effect of putting really nasty mains. Like, they create noise on the rest of that main circuit. But there's multiple ways that could be then getting into the circuit that the subs are connected. So I would need to see more of that electrical diagram of how the whole house is wired, what kind of dimmer it is, how it works. I couldn't guess.
Most commonly, it's a ground loop. You can test this in a few different ways. You can plug the sub into the wall using, at least if you're in the US, you can use a cheater plug to eliminate the ground lug to see if that eliminates the ground. That you don't want to leave it that way, but you can do that as a test. Does the hum go away? If it's XLR, you can use an XLR extension cable and then pull out the ground pin and see if that gets rid of it. Those are the two easiest tests.
So an interesting one, if cutting the ground works, you'd have to check your own electrical code if it's legal where you are. But I've used a product before that is made by a company called iFi. Other people might make these. It's IFI. They have a product called a ground defender.
I have one.
Right.
They work sometimes. They don't work other times.
Sure. So what I like about a ground defender is it is lifting the ground, which in theory is bad, but it's safety protected. So if there is a fault, you still have ground protection. It basically reestablishes the ground if it's needed, like the opposite of what a breaker's doing. It's putting the ground back into the signal at a point a safety fault requires it. So it would depend if lifting the ground on the power helps. If your electrical code allows it, something like a ground defender from iFi might be, they're not very expensive, and it might save you doing loads of rewiring and fixing it some other way. Here we go. I think we're going to see it. Maybe not.
I'm trying to find it. I've got a few devices that do it.
Okay, I've not used others. I had an issue on a project, and that worked for me. And every time I've had to deal with that issue, and I need a quick fix, I've always used the same one. So Ryan's saying there are others.
I found one of my XLR ones. So there's this is sealed. How do I even open this? Oh, it opens like that. So the ground defender kind of looks like this. This is an XLR one. So it's a ground lifter is what it does. And this is effectively just eliminating the ground pin. You can do this. You don't need devices like this. You can do it on an XLR cable, just pulling the ground pin. But the ground defender is kind of doing the same thing. Sometimes they work better than others. Depends on the situation. I would start with a cheater plug. You can buy one from a big box store for like a couple bucks or Amazon and see if that eliminates it. Sometimes you can get like a true power conditioner that can get rid of them. Furman makes some good ones. They don't have to be expensive. They just need to do what they're actually saying they're doing. And you're not going to get magical audio properties out of it, but it may eliminate the hum depending on what it is. I would start with a cheater plug. That's the cheapest way. And technically you can still ground. It's got If used correctly, you would ground it somewhere else to like a chassis or something. But it's probably a ground loop, and they suck. They're a pain in the ass to troubleshoot, especially if you're trying to get.
So the very most important thing, if you are playing at all with your ground, and I don't know which country you're in, I don't know what your code says, but keep your family safe. Don't do something stupid which introduces an electrical risk. If you use a cheater plug where you've just lifted the ground and it's temporary for 5 minutes and it fixes it, then go and put a proper solution in place.
Oh
Do not
dear.
leave people at risk, because that's really fucking stupid,
Yeah.
and don't do that.
This may be part of the issue. I ran XLR cables through the wall when I built the home theater room, but I'm using XLR to RCA adapters at either end because my current processor only does RCA. I ran XLR to future-proof the processor. So now the RF thing that he's saying makes more sense.
Yeah.
The distance, it could be a power wire that you're crossing, honestly, because it's not XLR, it's not rejecting noise. You know, the other thing that you could do that's not an ideal solution, but it does work pretty well on subs, is do wireless.
So the first thing would be, what kind of adapter is it? Is it one of these little bullet, low cost, like $2 bullet size, just straight converters? Because there are proper like balanced transformers that you can use that will probably behave differently. I'm trying to remember who makes the one I'm thinking of. In fact, I think Nutric even make one that is a proper impedance matched device. I'm sure there are loads of others. There's one that is quite famous for working really well, and I can't remember who makes it. But you may need a proper balanced to unbalanced converter to convert that cleanly.
All right. We got one more question, and then we're done. It's been a 2-hour stream. I love these streams when they're about this long. It means we got a lot of questions. Isaac6626 says, I came in late. Sorry if this has already been addressed. In surround sound, not all speakers are active at the same extent at the same time. What do we know about this in relation to actual amplifier power? This changes depending on content.
Yeah. I'm going to try and find it, and I bet I won't find it quickly. I have a screenshot somewhere looking at the the input meters on the Trinnov for different content. And so here's the thing, right? You have to plan for worst case, because it's really easy to say, oh, they're never all driven. I don't need all that power all the time. But what's the worst case? What are there any films that you may ever watch that are pushing 5, 7, 9 plus every channel you've got, essentially, as hard as they'll go at the same time? Yeah, it exists. Like,
even more so in multi-channel music. That's taking more use of those surround channels. Or if you're doing things, and a lot of people do this, all channel stereo will push things to a harder extent. So there's a lot of variables. But again, at the end of the day, you've got to consider, what is your use case? How are you using the system? What is the content like that you're playing? And then make a best case determination.
yeah,
Just know that in the majority of those situations, the LCRs are going to be the primary ask.
It doesn't appear I've got the screenshot I was looking for on my desktop. It's probably on one of my laptops. But yeah, there is content. It does exist, even if briefly, where multiple channels are pushed really hard at the same time or close enough together that the power supply won't have recovered. Like, this is the interesting thing, is that kind of recovery time. When you have a big transient, does the power supply in that amp have enough room to get itself back under control, ready for the next one? So it doesn't necessarily matter if all channels are being driven exactly coherently. If you've got transients that are happening very quickly from one channel to the next, like really fast, the power supply is still going to get bogged down. You're still going to get rail sag. So I have an issue with only showing 1-channel driven and 2-channel driven data. I think it's completely stupid on multi-channel amp. I am going to quickly check the RP1 spreadsheet. I'm not going to read any more of it than one, because if you miss this bit, this is what CDS standards will ask for. It's under peer review. It's not public, but I am pretty sure if I scroll down to power output, it would help. Oh, I am on amps, right. I'm pretty sure we ask for it all channels driven. Okay, I now can't see that, but it will be, right, we've got long-term bursts, short-term bursts. I'll confirm, but we definitely have more information than just 1 and 2 channels driven, because that just doesn't tell you enough about how that amp behaves when 4 or 5 or 6 are being driven.
Okay. Anything else you want to talk about? It's a good stream. Oh.
No, I mean, I've already bashed why most typical ABX tests of amplifiers probably aren't particularly valid. I think that's the most controversial thing I've said so far.
I thought it was funny that you thought I was going to disagree with you.
No, I had a suspicion that you were going to say, based off other research and other listening tests you've done, that all amps sound the same, and if you don't need more power, you don't need more power, and all amps are the same. Don't waste your money. But you quickly seem to have agreed with my theory that actually maybe that's not the only story at play.
No,
there's more to this.
Not. Absolutely not. That's like saying I'm going to use a 5-watt T amp, and it's going to sound the exact same as something that's capable of 1,000 watts when that you're asking for 1,000 watts. The T amp may light on fire when you're trying to get it to do that.
It's fun because I don't watch anyone else's content, so I'm aware of some content other people have made.
Oh,
in the industry, right? So I do not watch any other podcasts done by I don't watch anything from our industry. I watch loads of, like, in my free time, I spend it on my pet projects and hobbies, right? I nerd out and other stuff. So, like, I've seen some of your content, like, oh, you know, at M-Wave we're doing this ABX, and or when we've done this test and no one can hear a difference. So I had a preconceived notion of what your view might be without actually researching what your view was.
Loser.
It's really bad of me.
Making assumptions. Making assumptions. But ladies and gentlemen, that brings us to the end. Thanks for all the questions. I always enjoy going through them. I think Ben does too, unless he secretly harbors hatred for me after every one of these streams when we go through and do these tests or these questions. But it's always fun going through everything. We will be back next Monday, I believe. Not sure on the topic. We keep thinking it's going to be dispersion, and then we keep talking about other things. I think it's always good to put a break in when we talk about the measurement data, because those get kind of boring, but it is really important for people.
Yeah, as Ryan will always say, not in the live feed, but in the actual comments, because we will read those later.
Yes.
If there's anything you want us to talk about, throw it in the live comments. And not the live, throw it in the chat.
VOD comments. Don't put it in the live comments, because we won't see those, but put them in the VOD comments of the video. If you guys have something that you want us to address, this one was good about, do you need a dedicated amplifier? I think for the general populace, the answer to that question is no, but if you are pushing to the limits, probably, but it depends on a load of factors. We'll wrap it up here.
Cool.
Thanks for the stream. Enjoy those home theater journeys. Stay safe out there.